Okay, so what is this HTTP protocol? Okay, so HTTP stands for Hypertext Protocol. It is used for it is the underlying protocol used by World Wide Web. It defines how messages are modified and transferred, what action web servers and browser should take in response to different command, and your entry, you enter a URL in the browser and HTTP command is sent across your web server to fetch and transmit the web pages. Okay, so let's see these. What does this protocol means? So this particular protocol has a lot of commands. Okay, like I'm sure you might have heard of this. Your get command, your post command, delete. There are various kind of such commands. So what you do is, when you say www. Google.com or whatever it is, in the back end, you are actually sending a protocol like this. Okay, you're sending a protocol like this. What you're saying is, get me that file. Get me that file. The file name is it's in this path, and yeah. And its name is file.html, and please use protocol 1.1. This is what happens when you type, say, www.google.com or not. Okay, so get is to get all your web pages. So this way, when I'm browsing, it's actually we are using a lot of these get, but it can also be used for other purpose. Now, imagine a situation where you're going to, say, doing a registration, say booking a ticket or whatever. In this case, what we're trying to do is we are sending some data which we have typed in our web page to the web server, right? And what happens there is this web server in turn captures all this data, and then it calls the respective language in which it is processed, okay? And it does the processing. It could be a submit or retrieval or whatever that may be, and it comes back into your page. So for that, we use this protocol called, okay, I think it's mentioned here. We use a protocol called post. So like that, HTTP has multiple protocols, get, post, what those things mean. Okay, so are you getting this? Any questions here? Okay, so this is how a HTTP program or a web server actually works. Then, if you have noticed, this HTTP server has a lot of these. You get this, numbers like 200 or 400, which is pretty much common. Okay, and sometimes you hear this fine. So if it's errors on your on internet are quite frustrating, especially when you do not know the difference between them. So these errors are called HTTP status codes. Okay, are response codes given by the web server, and these help in identify the cause of the problem. So what are these? It's important to know these codes, and it helps you to debug this. These information codes, 100 means it is continue. That means it's just an informational code. If it's 200, that means the web page has been downloaded and there's no problem. If it's 300, that means that URL does not exist and it's redirecting you to another place. If it's 400, that means that URL does not exist. And if it is 500, that means I think if you've been developing any applications, you would have noticed when you notice that the web. So when you are kind of doing a registration, you have to call some programming language. If the programming language, in a simple case, may not have an execute permission, then you also get such errors like this. Okay, so this is where these errors are, and they are these are the different types, and that's how you know your status of your web as such. Okay, now there are actually so many web servers that are in the market. So many of them. The most popular is Apache, and today the second most popular web server is what is called as Nginx. Okay, I'm sure you might have heard of this. It's becoming the second most popular web server in the market, okay. Followed by your Microsoft's IIS, Internet Information Server, and a host of other servers that are there. But Apache 10 continues to be the most important and the most powerful. Okay, the most important and the most powerful, and Nginx kind of coming up to be the next most important. Now, the configuration of your Apache, now that's a very simple thing. You have to install your web server, okay. That is through either, it could be, if it's CentOS, it's going to be HTTPD installation. Then it just has a single configuration file, okay. So it just has a single configuration file, which is called your http.conf, and the directory where all your objects are kept. When I say object, this is your images, your HTML files, or your or any other files that you want to serve through the web are kept in this particular path. Okay, so this is how this is configured as it. And then of course we're going to do the labs of all of these things. Any questions? Okay. Then once you have configured it, there is you start your service. The service is called HTTPD. Okay, and if you make some changes in your HTTP conifer, and if you want to immediately take effect, we do this command called reload. Okay, so it will be example like adding a new domain into your configuration file. So we add this and then we reload the whole stuff. Okay. Okay, so if you look at your http.conf, you will have a lot of these configuration setups, and some of all are all these, like root server. This specifies where your documents are going to be located, and in this case, your var whtml is your root server. Okay. Then keep alive. Whether server allows one or more requests per connection. Okay, I'm not sure how many of you all know this. When I do a browsing through any of the browser, it is not a single connection actually. There can be multiple connections. So what happens in multiple connections means that I'll be opening two different sockets to connect to this particular server, which actually just helps in improving your speed and things like that. Now, keep alive is another situation where I do not want to creating socket every time I try to connect to a web server, and anytime I also connect to a web server, I want to use that existing connection to actually send the request. Else what happens is, if I don't say keep alive, I'll be keep opening up and be sending my connections through new sockets every time I want to process something. So this helps in kind of doing a single pipeline is always opened up to do it multiplexes. Basically, it multiplexes. Start servers sets how many server process you have to start. So when an Apache starts, there is a server which starts up. Okay, so what is this is so this server handles each of your client requests. But if there is only one server and then I can only start, then only one guy can actually connect to it. So, but what he does is he starts child process. So max request, the total number of requests each child server process serves before the child dies. Okay, so that's your child process. And max client sets the total number of server process that can run at one time. So what that means is when somebody says that I'm able to process 1,000 requests per second, it means that the server is designed to handle 1,000 clients simultaneously, and that's what the max time. Okay, and then you have the min spare and max spare. If number of servers waiting for a request is less than min server, it creates some, and if the number of servers waiting for request is more than max, it kills some. So what this does is, see, I'll tell you why Nginx has become so popular is every time I have to connect to a server, I will have to spawn a socket. Okay, I will have to spawn a socket. The spawning of the socket is a very expensive process within your server, and it takes definitely some milliseconds for this to happen. Now, if there are thousands of them, it's very difficult for your server to handle, and it starts going slow. Okay, so that is why sometimes you instead of waiting for some client to come, you keep some minimum servers ready, and if you feel that it is actually going, it's not going only going the, I actually kill this. So that is what this min and max servers are. Okay, any questions? Okay, so yeah, as I said, it's the most widely used. It's an open source. Rather, every flavor of Unix actually has its own. So you might have heard sometimes there's an IBM HTTP server, Oracle HTTP server. Now they are all Apache servers rebranded by these organizations. Basically, they're using just Apache as the server to do the services. Okay, so as a part of so the whole idea of having a web server is definitely to do some kind of content serving. Now, for this content serving to happen, we have to integrate this toward DNS. Otherwise, we'll have a problem, right? That's what we have seen. Now, how the web server itself is placed in an organization depends on how do you design your firewall. And as always, as I said, firewall has three legs: your public side, your private side, and what is called as the DMZ, or the demilitarized zone kind of a site. Okay, so all your web servers or any server that needs to be internet facing are kept in your public side, in your DMZ side, and all the DNSs and all the DNS entries which needs to talk to these servers are kept in the public DNS, not in the internal DNS. Okay, so that you need to understand. If you keep this in the internal DNS, then the public who's going to come will never find this server. So you understand, I'm sure you understand why it has to be kept in the internal. Now you also get a confusion here. You have an Apache server which is serving the internet, right? But what about the internal users? So what they do is, now to handle such a kind of a scenario, internal DNS will have to create its own entry to actually point to this part. So normally they don't do a forwarding. They will create another pointer to this to the web server so that it could handle both. When you are in the DMZ zone, you could move from internal to DMZ, but not to the external side, and the external could come from outside to the DMZ. So DMZ is like a quarantine. Yeah, it's a bit of a quarantine. It's a controlled area where people from both places could come and interact. Yeah, and you know it, and this is to keep all other unwanted users away. That's the whole idea of this particular setup, right? Apache can run in two modes: preforked and worker multiprocessor mode. Prefork mode creates one thread per process, each of which handles one user request. In prefork mode, process handles one connection only. This process is thread safe. Whereas in worker mode, creates new process too, but each has more than one thread, and each of which handles one request per user. In worker mode, processor handles more than one connection. Okay, see, this is an architectural design of your application. Okay, so there are two ways for your application to be designed. Okay, now let's take a telephone example. Try to answer this particular solution. Okay, now if I'm making an individual call, I can't talk to anybody. Neither the person on the other side can talk to anybody, isn't it? It's just a one-to-one connection, and we can't just get out of that loop, right? But imagine if you're doing a conference. We have simultaneously many people handling, many people coming in and talking, and then it's a completely two-way, right? It's a two-way talking, but it's a conference. There are multiple guys who are getting connected there. So Apache server has also been designed in there. When I say preforked, it is one-to-one. And when I say multi-worker mode, that means one socket can handle multiple connections. Okay, so what is the advantage? See, there was this challenge called C10K, C10K. Now, this particular challenge, I probably do not know who might have, who actually started off. Of course, you can see it on the net. Is the challenge was, can I use my existing web server, and can I have 10,000 simultaneous connections? I'm talking of not the present servers, the earlier servers. I think these were the times when you had that 1 gig processor. Can it handle 10,000 connections? Apache server could not, because to handle such a kind of a connection, you need to have very fast CPUs and equally good amount of memory. Okay, only then you could handle. Now, so they realized that in a preforked environment, this would not happen. So they designed this architecture of worker mode way of processing, in which if I have 10,000 connections, right, I would not open 10,000 sockets. I will, in your worker mode, I won't open 10,000. I will just open up some 10-20 of them, and these 10-20 can then handle actually 10,000 people. So that's the architectural difference. Just like how your the analogy is basically the way group chats and group conference calls work. That is the whole, where there is a way of slicing and weighting and dicing. I mean, a lot of things in terms of how that multiplexing happens there. It's a time division there. Each, though it appears that everybody is together, there is definitely a serial way of connection which is happening, but we do, because of the speed of the process, we are not able to feel that. You feel all of them are happening together simultaneously. Okay. Are you getting this? Any questions that are arising in your mind? Okay. So yeah, the limiting factor, as we all know, has been the memory, which has always been a problem for all the internet-facing web server, the servers, right? And the potential to deadlock threads that are contending for the same CPU and memory. So if a thread is stopped, the user waits for the web page to appear until the browser makes it free. So it can send back the page. If a thread is deadlocked, it does not know how to restart, thus remaining stuck. Okay, so when does a deadlock happen? Deadlocks happen when there are too many threads. If there are too many threads, I mean, we know, right? When there are too many people, there is a general chaos. If they are trying to seek an attention of some particular stuff, right? So the same thing happens within the CPU itself, and we don't know how the deadlocks happen, right? Because everybody are given a certain amount of time to process, and during this time, if that particular web page is he is not able to get, then there may be other guys who are trying to vie for that CPU time, and during this process, certain threads can just get hung, and it gets hung, and then nobody is able to process. So that's why these deadlocks kind of happen. It could be any reason. We really don't know how and what is the reason behind a lot of these deadlocks.